All right, everybody. How are you today? Week 13, lesson number 2. Let's proceed as we're finishing strong toward the end of the course. For today's agenda, homework answers. Today's do it will be some praxis power study. Almost the end of the semester, finish strong. And then more, not more statistics, measuring distribution, expected values, box and whisker, and stem and leaf. Here's the first set of answers. And the second. Okay. Praxis power. Performance is a function of preparation. Truer words were never spoken. Give it a shot. You know, of course, we're doing stop and start. Okay. So, you're looking for the steepest or the biggest jump up or the steepest slope. And as I look at that, it's over on this part of the graph right here. So that gives me 2006. From 2005 to 2006 is the steepest jump. Try this one. Okay, so when you line up the percentiles of a score, the highest score means you're at the very top of the chart. Okay? And percentile is how many are below you. So if you're at the 99th or the 100th percentile, there's no 100 choice here. That means that 99% of the scores are beneath you. You beat 99% of the scores. Okay, try this one. Okay, so approximately how many total students were surveyed? So I count the ones here, 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 and here in each of the bars. I measure how high they are to the best of my ability and I add them up. So if I add up all the heights, I misspelled that, sorry. I get 58, 7, 35, 12, and 18. Add them all up, that's about 130. Notice the choices are spread pretty far apart. They don't have like 127, 128, 129, 130, 131. They do that on purpose, so there's no question as to what the right answer is. Okay, some modified true and false about what we studied last lesson. Give it another few seconds or so. Okay, so average is also known as the mean. That's true. In finding the mode of data, you should arrange the data from highest to lowest. And I think that the key word is here is you should. You don't have to, but you should because then you won't miss one. So that's true also. Mode is the number that occurred in the least, or that occurs the least in a set of data. That, folks, is false. Mode occurs the most in a set of data. Median is finding the middle number. That's true. Remember, when we think of medians, we can think of, you drive down the road and you say, or they say, stay off the median. What that means is that strip of grass in the middle of the two roads. So we don't want any part of that, nothing in the middle of the two roads. Okay. If you have two numbers in the middle, you should get the difference and divide it by 2. That's false. To find the median, you should get the sum and divide by 2. Okay. The mean of 23, 56, 45, and 30 is 38.5. Just add them up and divide by 4. That's true. The median of that set of data is 19. That would be false because they forgot to line them up in order. If you line them up in order, it goes 18, 19, 22, 26, 35. 22 is in the middle. The mode or modes of the given data, 11, 10, 12, 12, 11, is or are 11 and 12. And that's true. You can have more than one mode. 11 and 12 are both repeated twice. Okay, give this a shot. Okay, so the probability of landing on red in a game is 1 out of 5. What's the probability of not landing on red? Well, if it's 1 out of 5 to land on red, then it's 4 out of 5 that you don't land on red. And that's 80%. Okay, try this one. Okay, so Marilyn selects a piece of candy at random from a jar that contains 4 peppermint, 5 cherry, 3 butterscotch, and 2 lemon. What's the probability the candy she picks is not cherry? So remember, probability is favorable outcomes, the number of ways to not be cherry. Those are 4, 3, and 2. If you add them up, you get 9 out of the total number of possibilities, which is 14. So 9 out of 14. Another way to compute the fact that you've only got 9 is you should do 14 minus 5. I know it says 1 minus 5, but 14 minus 5 over 14. Or you could look at it as 1 minus the fraction 5/14 over. And then when you do that, you get 9/14. Okay, try this one. So statistics is an important part of the test, and that's why we're making it a point to really hammer them home now that we're at the end of the course. What is Beth's mean daily salary for the week? So Beth is the orange one. So I'm going to add like 60, that's probably 55, 30, and so on. So 60, 55, 30, 60, 50, 50, 70. Those are the 7 days. If you add them all up, you get 385. And then you divide that by 7, you get 53. So I would say about $53 is the daily salary for the week. Okay, give this one a try. Okay, so Juan received scores of 82, 76, 93, and 80 on his first 4 chemistry tests. He wants to get an 86 average. So what does he have to get on the next test to achieve an average of 86? You know, I was real concerned about my grades in high school, and I can remember just doodling these kinds of answers to myself. What do I need on the next test to get a 95 average in chemistry? So this rings home. Juan and I are a lot alike. So your mean is your average. The average is the sum divided by how many there are. If the mean is 86 and there are a total of 5 scores, then 86 times 5 has to be 430 points. But of the scores listed, they add up to 331. So the missing score, has to be a 99. The Mets just beat Milwaukee tonight. Not that I watched any of that game. I've been doing a whole lot of stuff and working very long hours, and that's why I'm a little tired. I won't even ride the exercise bike tonight. Okay, which correlation shows a causal relationship? Remember, this is view, and you should be able to show a link for it to be causal. Okay, so in this case, the one that's definitely causal is the more gasoline you purchase at the pump, the more you pay. That makes sense, right? The others, you know, you could stay at the mall and not buy anything. Well, you might not be able to, but I can. I can do that very easily. Just because you're an athlete on the playing field doesn't mean you're going to score more goals. For instance, a goalie in hockey doesn't necessarily score more goals. And as the price of a gift increases, the size of a gift box increases. I don't know about that. I bought some pretty expensive pieces of jewelry for my wife over the years. Okay, now, everything we've done so far is review. This is new stuff, the stem and leaf plot. And it looks like it's shown right here. A lot of these you would have covered in public school or in like high school and so on, middle school. So the big thing to remember about stem and leaf plots is the stem is the beginning number and the leaf is the number at the end. So this is like 0, 1, 0, 5, and then 12 doesn't start with a 1 or a single digit. So all the ones that start with a single digit of 0, because 1 is really 0, 1, 5 is really 0, 5, they get listed out. And then 1, all the ones that begin with a 1 get listed out. And then all the ones that begin with a 2. And here's the thing about the stem and leaf plot. You have to put them in order. Here's the second thing. If you notice the second diagram, it says key 9/6 equals 96. You really should include that key all the time. Now, why this website over here didn't, when it's clearly the same company, I don't understand. But it is what it is. So on the one on the right, everything begins with the 90s, the hundreds, or the 110s. So 90s start with a 9, the hundreds start with a 10, and the 110s start with an 11. So 91, 92, 96, 99, 102, 103, 103, 103, 108, 109. You can see how this will help you find the mode instantly. And the thing is, with a stem and leaf plot, you have to put them in order. However your scratch work is, however you do your scratch work is your business, but you must, the final answer must have them in order, and that helps you in finding the median also. Helps you a lot. And then we're going to do this thing called a box plot, which it will help with as well. Okay. So find the mean, median, mode, and range of this box plot. Stop and start time. Okay, so 1 is 51, 5 is 55, and so on. So 51, 55, 58, 60, 63, blah, blah, blah. It's 603 divided by 9, which is 67. So that's your mean. The next one would be the median, and that's 63. And if you notice, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. So if you have 9 scores, the middle score is going to be the fifth score. 1, 2, 3, 4, 5. There it is. That number is not 3, it's 63. So the median is 63. There's no mode. There's no number that's repeated more than once. Okay, there's your key. 5/1 equals 51. The range, now I define it here for you. You may or may not have remembered it. Range in statistical use is defined as the highest value minus the lowest value. So 83 minus 51 is 32. Okay, what's the median here? Okay, there's 16 scores, so between the 8th and the 9th will get you the median. 16 scores, so there'll be 2 scores in the middle. Between the 8th and 9th would be 2, 4, 5, 6, 7, 8, and 9th, and they are between 79 and 81. So then you take the average of those two. The average of 79 and 81 is 80. Of course, there's your key, which is very important to have. I don't know why I wrote 81. It only went up to 81. It should have gone all the way up to 80. All right, so those are reminders about stem and leaf plots. Now we have box and whisker plots. By the way, the other night, I made up your final exam. There will be a question or two on stem and leaf plots. There will be a question or two on box plots or box and whisker. Different people call them by each of those names. So be prepared and be ready. Now, when you draw a box plot, there are certain key markers on it. The first one's the minimum, the lowest score, and the maximum, the highest score. These little bars over here or lines, those are whiskers. Then we begin 3 vertical marks, and they're very important what they stand for. The first one's the lower quartile. Talk about that in a minute. The one in the middle is the median, and then there's the upper quartile. When you divide the median down the middle, well, not necessarily the middle, but when you mark the median, then there are going to be half the scores below the median and half the scores above the median. So you then find the median of the lower scores, the half of the scores below the median. Find the median of those lower set of scores. That's your lower quartile. And then the upper quartile is the median of the above set of scores. And like range is higher minus lowest, if you do interquartile range, that's the range between the upper and lower quartile. Let's apply some and see. Again, here's the marks. Okay? Your box and whisker plot, there's your whiskers. Maximum, minimum, lower quartile, upper quartile, median. Notice you put a box around it. That's the name, box and whisker. We did it up here too. A box around those numbers, featuring the vertical lines, minimum, maximum. Okay, so now this time I want you to look at this particular graph and label, label the minimum, maximum, lower quartile, upper quartile, and median just by looking at the chart. It's my dog chewing a bone, don't worry. Okay, so now looking at this, the minimum is 18. Here it is. The maximum is 31. The lower quartile or the first quartile, those are the same thing. Lower quartile, first quartile, is 22. Your median is 24, and your third quartile or your upper quartile is 28. Let's do this one for blueberry pies sold each day. I used to live on Long Island, and we used to have a place called Harvey's that had the most wonderful blueberry pies. Man, did my dad love them. So give this a shot. Go ahead. Okay. Find the lower extreme or the minimum. That's 1. Find the upper extreme or the maximum. That would be 8. Here it is over here. The 1, the 8. First quartile is this mark right here. It's a 3. The median, 4. Third quartile, 5. Interquartile range is highest quartile minus lowest quartile. That's 5 minus 3, which is 2. Okay. 6th grade math test. Find the same values. All right. So here we go. Here is my minimum or my lower extreme. That looks like about a 68. 69 maybe. Over here, that looks like, again, either a 98 or a 99. And as we showed you in the previous problem a while ago, they're not going to give the choices so close that you're like, oh, I don't know. No, they're going to be far enough spread apart. The choice is made for you. First quartile is right here, 78. Next quartile, next one is the median. Median's in the middle. That's the easiest one yet, 85. And for the upper or third quartile, that would be 93. And the interquartile range is the 93 minus the 78. And 93 minus 78 is best known not as 17. It should not be 17, so ignore that. 93 minus 78 is best known as 15. Okay, which class has the greater interquartile range? For which box plot measure do both classes have the same score? Okay, clearly the greatest interquartile range is the top box because the scores from first quartile to third quartile are spread apart. One of the other things that's important to understand about box and whisker plots is 25% of the scores go on the whisker on the left, 25% go on the left of the box, 25% go on the right of the box, and 25% go at the whisker on the right. Same is true for Class A, 25%, 25%, 25%, 25%, adding all, of course, to 100%. Which has a greater interquartile range? Class B, because that's a bigger, wider, spread out area. Which box plot measure do both have the same score? Right here. That would be what? The first or lower quartile. All right, next. Oh, I don't want that. Oh. Find the range. First quartile, second quartile, third quartile. Now, the second quartile is also known as the median and the interquartile range using box and whisker. So they're not asking you about minimum, maximum, just all the others. Go ahead. Okay. So the range is going to be the highest minus the lowest, which is 90 minus 25, which is 65. First quartile is 40. There it is. Next, median, quartile 2, right there, 65. Quartile 3, 80. Interquartile range is 80 minus 40, which is 40. Minimum. Oh, you have to draw this, okay? Here's the scores. I rewrote them in order, And you need to draw the box and whisker plot on that. Go ahead. Okay, so the minimum is 71. The first quartile is 72.5. The median is 78. Third quartile is 80.5. The maximum is 84. So let's mark it. Here's 71, 78. That's over here. Oh, okay, hold it. 71, 72.5, 78, 80.5, and 84. Put a box around those middle numbers and whiskers. So there's your box and whisker plot. Dot plot. Basically, a dot plot's a way to keep track of frequencies. In this case, each dot above the 0 means there are 2 zeros. The 3 dots above the 1 means there's 3 ones in the data set. The 5 dots above 2 means there's 5 twos in the data set, and so on. How many people in this diagram, the paint orders, ordered 5 or more gallons? Well, there's 2 here, 3, 4. So 4 people did. Students timed how long it took them to eat their lunch. The dot plot represents the data. How many students took 8 or more minutes? What percent of students ate their lunch in 5 minutes or less? And what's the average time it takes for the group of students to eat their lunch? Go ahead. Okay, 8 or more is over here. That'd be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. What percent ate in 5 minutes or less? That's 1, 2, 3, 4, 4, 5, 6, 7, 8 out of 19, which is 42%. What's the average time it takes for the group of students to eat their lunch? Well, this is painful, but you got to add them all up and divide by how many there are. So 112 divided by 19 is 5.9 minutes. Try this dot plot problem with a set of problems. Okay, students in a social studies class were asked how many brothers and sisters they each have. The dot plot shows the results. So in other words, interpreting this correctly, there are 3 that have no brothers or sisters. There are 3 in the class that have 1, 3 that have 2, 6 that have 3, 4 that have 4, nobody has 5, and 1 that has 6. How many of the students have 6 siblings? 1. How many of the students have no siblings? 3. How many of the students have 3 or more siblings? So that's these guys plus those guys. 6. 4 and 1 add up to 11. And X is just like a dot. Go ahead. Figure it out. So, what's the range? From 85 to 79, so it's 6. How many boys had a pulse rate over 81? These 3, 7, 9. And how many boys had a pulse rate of 83? 1, 2, 3, 4. All right. Last thing we get to, scatter plots. So what scatter plots do is they just take an input and an output, or independent and a dependent variable, like how many hours you studied and what your score was. And they plot them on a graph. And they make lots and lots of points. And they look for general tendencies in drawing conclusions. So this might be typical for hours spent and then test scores. Not everybody's test scores are going to go up by the same amount when you spent hours doing it. Oh, one other thing. This guy out here in the red circle, that's called an outlier. It's far, far, far away from the rest of the statistics. Okay, we did that one. First thing about scatter plots is they're a lot like slope. Any slope that goes up like this is a positive slope, so that's a positive correlation. If it goes down, it's a negative slope, so that is a negative correlation. So if you remember slopes, you remember these. No correlation means it's not going up or down. It's just kind of fuzzy and spread out all over. Now, just because it's going up doesn't mean it's a perfect correlation. It's only a perfect correlation if all of the points are exactly on a straight line over an interval. If you're really highly positive, that would look like your second one. Okay? Notice they're really tight over here. That's perfect. They're pretty tight here, so that's a high positive correlation. Here, they're more spread out, so that's a lower positive. So for numbers, this might be 1 or 1.0. This could be about 0.8, pretty good. This would only be about 0.3. Now, no correlation is if the correlation is 0. And there's a correlation of 0 right there. It's a horizontal line. Now we're getting into a negative correlation. And what that means is it's a low negative. And then we get a highly negative one where they get really tight. And R's value here is negative 0.3, negative 0.8. Okay. So notice the ones that are packed more tightly together, have a higher number. So when we want to see which has the best correlation, we ignore the plus and minus. We take the absolute value of it, okay? So here's one. This is a strong positive. This is a weaker positive, right? It's still positive because it's still tending to go up and to the right, but it's not nearly as strong. Strong negative over here. Okay, that might be negative 0.9. This might be positive 0.9. This might be positive 0.4, and this over here might be negative 0.4. That's a weak correlation. All right, positive or negative for each of them, and which one is a stronger correlation? Okay, positive correlation for both, and the stronger correlation is on the left. Positive correlation, remember, goes up and to the right. Negative goes down and to the right. No correlation as they're spread out all over the place. So here are 4 examples. You determine the type of correlation, positive or negative, and guesstimate the R value. Is it really close to a 1, positive or negative, or is it a little more spread out than that? Okay, number 1 is positive, and I'm guessing about 0.7. It looks pretty good, but not perfect. Number 2, no correlation. They're all spread out all over. Number 3, that's really good negative correlation. An example of a negative correlation might be you're looking at how much money you have in the bank and how many hours you spend shopping. So the more hours you spend shopping, the less money you'll have in the bank. That's a negative correlation. One goes up, the shopping. One goes down, the money in the bank. In this case, I would guesstimate maybe negative 0.9. And then the one on the right is still nice too. It's positive, but it's 0.8, not quite 0.9. Now I want you to understand, the one with the strongest correlation here is choice 3. The negative in front, that only indicates the direction. As one goes up, the other goes down. The correlation itself, how tight it is, negative 1 is just as tight as positive 1. They're equal, okay? So if you look at the dots on the third example here, you could see that those dots are tighter packed than any of the others. So that has the strongest correlation coefficient. Okay? And the last thing I want to introduce you to, and we're going to save most of it for the next lesson, is this idea of a linear regression. You can put the dots of a scatter plot on the graph, and you can try to draw the line that does its best at going right through the middle of all the data. And you can get an equation for that line, okay? The cool thing about that is you can then use it to guesstimate, and we will cover that in the next lesson. The happy recap. We talked about ways of organizing data, box and whiskers, box plot, etc. Stem and leaf plots. Stem and leaf help us order data. That's what that's great for. The box plot helps visualize spread, dispersion, quartiles in the interquartile range, and scatter plots and correlation coefficients. It doesn't matter whether it's going up or down. Whichever one has the most tightly bunched group of dots is going to be the stronger correlation.